Hi, this is Mrs. Moret with tonight's homework. So we're in Unit 2 doing Lesson 12. This is in your textbook beginning on page 239. And you have to do numbers 1 through 4 and 7 and 8. So let's get started. Number 1 says the knitting club sold 40 scarves and hats at a winter festival and made $700 from the sales. They charged $18 for each scarf and $14 for each hat. If S represents the number of scarves sold and H represents the number of hats sold, which system of equations represents the constraints in this solution? So the first piece of information is we know they sold a total of 40 items. So I would say we could represent that with scarves plus hats equals 40. So that's going to be one of the constraints. The other one comes from how much money they made and what they charged for each item. So I know that scarves are $18, so 18S. And hats are $14, so 14H plus 14H. And they brought in $700. So it looks like that is the same as answer choice C. On number 2, it says, here are two equations. Decide whether each XY pair is a solution to one equation, both equations, or neither of the equations. To answer this question, I went ahead and put these equations into Desmos. So here's the two equations from that problem. And so if we look at the answer choices over here and compare it to what we see on the graph over here, we can determine how that's going to work out. So the 0.34 is about right here, and it looks like 3,4 is just for the first equation, just a solution for the first equation because it's on the red line. The 0.4 and then 2.5, 4 and 2.5 appears to be the solution to both equations, the solution to the system actually. So answer choice B is for both. The 0.55 is up here, and it looks like it's just on the blue line. So that would just be the second equation. And then the 0.32. Well, 32 is kind of out in space, not on either of the lines. So I'm going to put it here so you can see. So 3,2 is that point I just put there, and it's not on either of the lines, so that one's neither. So just to wrap that up, so the 0.34 was just on the first equation. The 0.4, 2.5 was this one, which is the solution, so both. The 0.55 is just on the second, so it's just a solution to the second equation, and the 0.32 is not a solution to either one of them. Okay, number 3 says explain or show that the 0.5 negative 4 is a solution to this system of equations. Again, I put both of those equations into Desmos, so turn these all off. And here they are. And right here, where the two lines intersect, is that point 5, negative 4. So we can say it is a solution to the system because it is the point where the two functions cross. Number 4, Diego is thinking of two positive numbers. He says, if we triple the first number and double the second number, the sum is 34. So triple the first number and double the second number. The sum is 34. So to write an equation to show that, tripling the first number, let's call the first number x, and the second number, we can call the second number y. So I'm going to actually answer in the space down here. So for number 1, tripling the first number means 3 3x, and then double the second number plus 2y. And since it says sum, I know I'm adding them together. And then is 34 equals 34. Then it says find 2 possible pairs of numbers Diego could be thinking of. Well, the easiest pairs of numbers to figure out might be making one of them equal to 0. So I know that if x is 0, then I'm just doubling y and get 34. And so all I need to figure out is what is 34 divided by 2? It's 17. So one possible pair of numbers would be 0 for x and 17 for y. And I'm just going to come up with a different pair of numbers if I just think to myself, well, what if x is 2? If x is 2, then what I know is that I could figure out the other value by thinking about, well, what do I get if I put a 2 in for x? If I put a 2 in for x, I have 3 times 2, and then added to 2y equals 34. Well, 3 times 2 is 6. Okay, so I can solve this equation by subtracting the 6. That gives me 2y equals 34 minus 6 is 28, and then dividing by the 2. 28 divided by 2 is 14. So there's 2 possible combinations. Number 2 is a different prompt. It says if we take half the first number and double the second, the sum is 14. So this time, half the first number would be 0.5x, and double the second number, then the sum is 14. So plus, double the second number is 2y, and that would equal 14. So there's the equation for number 2. And then number 3 asks, what are Diego's 2 numbers? So you could use the space in your textbook to draw the graph and find where those 2 equations intersect. And I put those equations here into Desmos. Here's the 3x plus 2y equals 34. And then the 0.5x plus 2y equals 14. And they cross right here. So those 2 numbers are 8 and 5. And the other problems you had to do were numbers 7 and 8. So number 7 is a story problem about looks like a field trip or to a baseball game. Volunteer drivers are needed to bring 80 students to the championship baseball game. Drivers either have cars, which can seat 4 students, or vans, which can seat 6 students. The equation 4c plus 6v equals 80 describes the relationship between the number of cars, c, and the number of vans, v, that can transport exactly 80 students. Explain how you know that this graph represents the situation. Okay, so here's our equation. And the equation makes sense since it says there's 80 students going, and cars can seat 4 students, and vans can seat 6 students. So I can see those clearly represented in the equation. And then remember, we did this with a similar problem having to do with carnival rides and games. So we could just use, find like if there weren't any cars going, so 0 cars, then how many vans would there be? To figure out the vans, if there aren't any cars, we would do 80 divided by 6. And so over here, I can calculate 80 divided by 6 is 13.3 repeating. And looks like that's about right there. And then on the other end of it, what if there aren't any vans? 0 vans. Then to figure out the number of cars, we would calculate 80 divided by 4. Well, I don't need a calculator for that. 80 divided by 4 is 20. And you can see that that's where it crosses the x-axis. So I can really confidently say that this graph represents the given situation. And number 8 gives us some hints about different siblings in a family, and they are doing a family-friendly running event. So based off of the clues and what we see on the graph, we are trying to connect each sibling to whether they are graph A, B, or C. So our clue, the oldest sibling begins at the start line. So the start line would be down here, and I notice there's 2 siblings at the start line, but they run at different paces. So the oldest sibling begins at the start line and runs 7 miles per hour, but then the middle also starts there, but that sibling is walking at 3.5 miles per hour. So both of them start right here. Notice that if a sibling is running, they'd have a steeper line because they're going faster. And so this would be the middle sibling. So the oldest sibling is graph B. The middle sibling is graph C. And then let's just look at the prompt to make sure the youngest sibling is actually graph A. It says the youngest sibling joins the race 4 miles from the start. And that looks like right here, 4 miles from the start, and runs 5 miles per hour the rest of the way. So not as steep as line B, but steeper than line C. So that makes sense that the youngest sibling then would be graph A. And that is the end of your assignment.